If you've ever put your thumb over the end of a garden hose to make the water come out faster, then you're familiar with something known as the equation of continuity. The equation of continuity has to do with the idea that the flow rate remains constant as the water comes out of the hose. So flow rate in the English system, flow rate is often measured in GPM. Now, what do we mean by that? GPM is gallons per minute. So in other words, it's an amount of volume divided by an amount of time. So in the metric system, we don't use GPM. In the metric system, we would measure volume per unit time as an amount of cubic meter per second. So that's what we mean by flow rate. So let's picture two cross sections of the hose. There's a cross section here, and water flows through that cross section. We'll call that cross section area number 1, and then the water continues and exits the hose at the right end. I guess I've got it backwards from the picture. My diagram here, water's flowing to the right, and so the water has to exit through a smaller area, area number 2, but the amount of cubic meters per second of water passing through this cross section has to match the amount here. So another way we can express the cubic meters per second, we could say cubic meter per second is the same thing as a square meter multiplied by a meter per second. Doesn't that equate to cubic meters per second? And so this would be the product of some area and velocity. And that's exactly what the equation of continuity says. The product of cross-sectional area and velocity at point 1 has to match the cross-sectional area and the velocity at point number 2. So the flow rate of water through this cross-section and the flow rate of water through this cross-section are equal. So if you want to picture that a little bit better, if a pipe is constricted, the equation of continuity is applied. Where's the water flowing faster? At point 1 or point number 2? Well, because point 1 has a bigger cross-sectional area, the velocity vector v1 is smaller, and the cross-sectional area is less at point 2, so velocity vector number 2 is larger. So wherever a pipe constricts, the velocity increases. So some people might think that the point of putting your thumb over the end of the hose is to increase the flow rate. No, the equation of continuity says flow rate is constant. You're not increasing the flow rate, you're just increasing the velocity. The flow rate remains constant. So once again, the equation of continuity, area 1 times velocity 1 equals area 2 times velocity 2. So if you want velocity number 2 to be greater than velocity number 1, that'll happen as long as area number 2 is less than area number 1. If we rearrange this equation, we can see it. V2 is equal to V1 times the product A1 over A2.